in. So if you need some Wi-Fi, we'll get going that way. So our next speaker is Lee Brandt. After almost 2 decades writing professionally and a few years unprofessionally before that, Lee still continues to learn every day. He's led teams in small and large companies and always manages to keep the business needs at the forefront of software development efforts. He speaks internationally about software development from both a technical and a business perspective, and loves to teach others what he learns. Lee writes software in Objective-C, JavaScript, and C#, mostly. It works on my machine. We've all heard it. Most of us have said it. It's been impossible to get around until now. Not only can Docker-izing your development environment solve that issue, but it can make it drop dead simple to onboard new devs, keep a team working forward, and allow everyone on the team to use their desired tools. Lee is going to cover the basics of Docker, how to use it to develop, and how to deploy your development environment as the production environment. So everybody give it up for Lee.
All right. How's everybody doing? Wow, that was kind of pathetic, but okay. If you guys are okay with that, I guess I can be. How's everyone doing this morning? Okay. I mean, geez, it's Friday. You don't have to go to work. And everybody's like moping about it. I don't know what the deal is. Okay. So, I'm glad you said something about the Wi-Fi because I totally forgot about it. And I do have everything I need on my machine, but I'm going to try and do a Docker pull and we'll see what happens. So, this is also a brand new machine to me that my work just gave me, so I apologize if I fumble around with it a little bit. So, I'm sorry, what was your name? Max. Like you said, I'm Lee Brandt. I'm not nearly as cool as that whole description make me sound. I have been developing software for 20 years, but honestly, the first 10 years were the same year. So I don't know if you've ever done that, like you don't have 10 years of experience, you have 1 year of experience 10 times. But once I started going to conferences and talking to other developers, things got a lot better. So we're going to talk about Docker today, and this is a beginning Docker kind of talk. How many people are pretty good with Docker already? Okay, so you guys are going to want to lean on something sharp in about 10 minutes. Just saying. So, I work for a company called Okta. Got the shirt on, so they're videotaping, so I have to. Ultimately, friends don't let friends write off. So, if you need authentication, the login page is the thing that fools you into believing that you should write authentication for your application, and then you end up down the rabbit hole of having to write a forgot email, password, workflow, user screens, all that other stuff. Just don't do it. Use a software. Even if you don't use us, use a supplier. So who am I? I'm a programmer, recently converted vodkatarian. It's a lifestyle choice. So, and if anybody would like to talk about it afterwards, I'll be happy to discuss it in depth over vodka tonic. So, most people know me from some of my previous jobs. Keeper of Keys and Grounds at Hogwarts, they know me from that job. Star of Finding Bigfoot, I've been on 3 seasons, they still don't have a picture of me yet. You know, I tell this joke all the time, and so we stopped at a rest stop on the way up to Omaha, middle of the night. We stop at a rest stop, and I'm walking through the parking lot going, this is not good. This is not good. My lumbering butt walking through a dark parking lot. I'm going to end up with a tranquilizer dart in my ass. I just know it. And somebody yelling, I got him, I got him. Okay, so very serious, very professional all the time, obviously. So, back in the day when you wanted to get a piece of software on a server somewhere, you went to the ops folks and you said, hey, I need to get my software on a server, and they said that'll be 3 weeks. They're like, why is that going to be 3 weeks? Well, I have to write a PO. PO has to be approved. That's going to take a week. Then I have to order the software. I have to order the hardware. That's going to take a week to get it here. And then I need a week to get it in a rack, get it hardened, get the OS on it, get any software you need on it, like IIS or Tomcat or whatever. Then you can put your app on it. Well, obviously, this is not ideal for us, but it's not ideal from a company standpoint either, because you can do one of two things when you buy hardware. And do the ops folks ever buy the Intel Celeron processor with 120 megs of RAM? No. They buy the one that's got 24 8-core processors, 5 bajillion gigs of RAM. They buy a server that could power NASA, right? And so they spend $10,000, $15,000 on this server, and when they put your app on it, turns out your app is an internal app for, I don't know, rating beers. You've got 200 users and your system is at like 1% load, if that, right? So once the CFO recovers from his coronary, from the amount of money you spent for 1% load, then you have to start thinking about, okay, how can I get more out of these servers that we bought that can power NASA? So we brought in VMs. Now VMs helped quite a bit. Are there any ops folks in the room? Any people who are ops folks? Okay, so a few. Same ones who are good with Docker, so they're just sitting in the back and they're gonna go for a smoke break here in a minute. So VMs are great, but I'm assuming that Wednesday is the loneliest day of the week for ops folks, where you have to log into each and every VM and make sure the patches are updated, unless you turn on automatic updating. I just wanted to see if the ops folks' head would explode if I said that. So now obviously there are scripts that you can write that do all this stuff for you, and that makes it a little bit easier, but wouldn't it be easier if you could just destroy and recreate the VM in the way that you want it? So the VM also allows us to create what's known as VM sprawl. So before you know it, I have this NASA server that has 40 VMs on it, all of them taking 4 gigs of RAM. And I don't know about you, but I get decision anxiety starting up a VM. I mean, how much RAM do I give it? How much hard drive space do I give it? I mean, it's really, if I need to up that later, do I have to take the whole machine down so that I can up that later? Most of the time the answer is yes, right? There's very little that you can change about a VM without taking the VM offline, okay? So obviously that's not ideal either. And you also have to pay for the same licenses for the same software. It doesn't make any difference whether they're on hardware or software. It doesn't make any difference whether they're virtual or not. So that's where kind of containers come in. And most of the time when I talk about Docker, the first thing I hear, well, actually, the first thing I hear is usually, I should learn more about Docker. That's the first thing I hear. The second thing I hear is, well, aren't containers just lightweight VMs? And if it helps for you to think of them that way, that's cool. But they're different in a lot of ways, and I'll show you why. So this is the slide that I'm most nervous about because it's got all the animations in it, and I moved it from a Windows machine to a Linux machine, so we'll see how this goes. I went through this last night like 4 or 5 times trying to get the animation right. So both of them start with a host OS, right? So you've got host operating system, and you're going to put these VMs or containers on. With VMs, you go ahead and put your multiple containers on there, or your multiple VMs on there. Then you put the operating system on each one of those VMs. Then you put whatever software you need to run your application, whether that's IIS, Tomcat, Apache, whatever it is. You can tell I'm a web developer, right? And then you put the app on each one of those servers. With containers, you put the containers on the server, and then you put your app on it, and you're done. And actually, that's a lie too, because really, generally your app is part of the container. I'm just so chuffed that the whole animation thing worked. I can't think right now. So, actually the app is usually part of the container. So generally what you do is you put your container out there on a server somewhere and you're done, right? And the reason that they can do this is because it shares the host operating system's resources, right? So this solves the problem of decision anxiety. Containers run kind of like apps. They'll take as little or as much memory as they need. Now, this can be a problem, obviously, if someone creates a denial of service attack against one of your servers, but you can limit each one of the Docker containers as well. That says, take as much memory as you need as long as you don't need more than 2 megs, or 2 gigs, right? Whoa, 2 megs. I just had a flashback to 1985 or something. As long as you don't need more than 2 gigs of memory, you're good, right? And that keeps a denial of service attack on one container from bringing down an entire server, right? So The other good thing about the fact that they run like an app, let's say you have a web app, your beer rating app is on a VM somewhere. When nobody's using your beer app, how much resources does the VM take up? And by resources, I mean how much RAM, how much hard drive space, how much CPU resources, whatever you gave it, right? If you gave it 2 CPUs, it's going to take up 2 CPUs. If you gave it 2 gigs of RAM, it's going to take 2 gigs of RAM. When a container's not running, when nobody's using your beer app running in a container, how much resources does it take up? Almost none, because it runs like an app. Apps don't take up any memory when they're not running, right? So that's the other great benefit. If you're Linux folks or Mac folks, one of the things that you'll notice is that for the Windows folks, Docker is still kind of janky. Microsoft's done a great job of trying to kind of make it work, but part of the reason that containers are able to do this is because Linux kernel is a monolithic kernel, okay? So when I'm running on a Linux box here, I'm sharing the resources of the Linux kernel that's underneath that. And no matter what distribution, whatever you're running, generally you have the same Linux kernel at the center, okay? And the reason that it's able to work on Windows or Mac is because basically it's running on top of a Linux virtual machine, okay? So you don't see that, you just go and install Docker and it looks like it's running on your machine. It's actually running on a Linux virtual machine. But Windows is a microkernel operating system, which basically means there's a bunch of little things that send messages back and forth to each other, and it's a whole lot harder to tap into those resources like it is on a Linux box, okay? So that's the reason it's still kind of janky on Windows. The other thing is, you need to know, if you're running a Linux box or a Mac, you cannot run Windows containers on that. You can, however, on a Windows machine, run Windows containers and Linux containers, because like I said, it's running on a Linux virtual machine underneath the covers. Also, if you're running Windows, how many people are Windows users? Am I like, okay, so we've got a few. I'm like, am I talking to a bunch of Linux and Mac people and they're like, I don't care about Windows people. That's what they get for using Windows in the first place. So I will let you know that the Nano server for .NET on Windows is a gig. Most of the other ones that we're going to look at today are 200 to 500 megs. So the full-on Windows server container is 10 gigs. So just be aware of that. If you're going to like push that out to a server and expect that thing to download, it's going to take a while. So how does Docker play into all this? The reason that Docker got famous, or the company Docker got famous, is not because of the misogynistic stuff they're doing now. That's how they became infamous. But they became famous because they standardized the container. Them and a company called CoreOS. They worked together and standardized the container, which made it super easy for things like Kubernetes to exist, right? So once they standardized a container, creating a container orchestrator is super simple. Creating an operating system that can handle containers becomes simpler. Obviously not as simple for Microsoft, but so I know what you're thinking, man, that guy's fat. No, you're thinking, come on, let's get to the demo part. All right, so can everybody see that okay? Bump it up just a little bit. Okay, so all the rest of this demo, that's the reason I brought the chair up here, because I'm 6'5", and like being hunched over for 30 minutes is not appealing. So I'm gonna sit down, and we're gonna look at two things that you need to know when you're dealing with Docker. First thing, the first two terms you need to get familiar with are images and containers. How many object-oriented programmers? So most everybody. Everybody knows the difference between an object and a class, right? A class is a blueprint for making an object. You can think of an image as like a blueprint for making a container. And actually, an image is really like a container frozen in time, right? That you can then hydrate as many times or in as many places as you need to. So, if I wanted to see what images I have on this this localhost machine here, first of all, one of the things that you can find out, I'll introduce you to Docker very gently with Docker -- version, because this is going to do more than just spit out a number for me. Oh, no, it doesn't. Docker info will tell me about a lot of stuff that I can do with Docker. But what we care about most is figuring out what images we have on our local machine. So we can do Docker image list, okay? And this is the new command. The old command is just Docker images. So, and I mention that because there's a lot of content written out there about Docker using the old commands, because the new commands are only about a year and a half old. So when you get out there and start reading more about Docker, you could come across a bunch of blog posts and things like that that are using the old commands. So I'll try and mention the old commands as we're going through here. So you got Docker image list. And this is really big and it wraps, but the biggest things to take note of here are the repository name over here on the side. And you can think of this like a Git repository. So you can version your containers the same way you version code. Everybody heard the term infrastructure as code? That's kind of what Docker is. It's just a bunch of code that tells Docker how to build your environment. So we've got the repository name. We've also got the tag. So here we can see I've got node 9.0. You can't really see it because it wraps pretty bad, but the tag is just like a GitHub tag or a Git tag in that I've got a version of this that sits right here. And generally you will refer to an image by its name and its tag, okay? If you leave off the tag, Docker is going to assume you mean the latest, okay? So, and I will say this for everyone who plans on using Docker, never, ever, 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 ever use latest in production. Just saying, because today's latest is not tomorrow's latest, okay? So, we've got an image ID, when it was created, and the size. You can see these are about 100 to 600 megs. Now, the way that I can start up a container from one of these images, or basically rehydrate this image into a container, is by doing a Docker run. And, let me start this back up to the top again. Okay, so the Docker run command, you can actually do a lot with the Docker run command. You can open up ports, you can make volume links, you can do just about everything that you can do in a Docker file, you can do in the command line with the Docker run. So I say that because Docker run is a really great place to try out stuff before you create a Docker file for something, okay? So, but we're gonna go ahead and we're gonna hydrate this Nginx 1.13.2, and actually, I am remiss, I missed one thing. If I don't have an image on my machine that I want, generally the place that it's going to look is at Docker Hub, and it's just hub.docker.com. And if I go and search for something like Microsoft, since we're beating on Microsoft today, I say beating on Microsoft, but I started as a .NET developer, so you can see here, or maybe you can see here, if I search for Microsoft, we'll have some that are Microsoft/.NET or Microsoft/Dynamics. Those are official images that are maintained by Microsoft. Generally, images will, well, they have to follow this naming standard of the owner / whatever the image is, because that first part of the slash, before you push it to Docker Hub, that's your username, your Docker Hub username. So all my images will be Lee Brandt / whatever the thing does, all right? So, getting back to here, if I want to get one of those, I would just do a Docker pull, and I could do Nginx and give it a version name number like 1.13.12, or I can leave that off. Wow, I just threw up in my mouth a little bit saying leave that off. So this would actually pull Nginx from Docker Hub. And unless you have some other repository configured, it's going to assume you want Docker Hub, which is fine. It's pretty standard. I will let you know there's a container out there for hosting your own containers. So it's kind of Inception-y, but you can get a container from Docker Hub to create your own Docker Hub and host it in a container. It's weird, but okay. So getting back to our Docker run, we'll see two switches here. Now the -it is not a word. It's two switches, -i and -t, and they're kind of combined together. And this says that I want to run a container from Nginx 1.13.12, and I want it to be interactive, which means I want to be able to interact with it, and I want to create a sudo tty shell, right? So I want to create a sudo shell into that container, which basically marries my terminal to the terminal inside the container, which means that since it's interactive and it's got a sudo tty shell, now I can actually interact with it on my machine. The last thing of note is this /bin/bash. For those people who are not Linux folks, I'm a Linux user, but I'm not a Linux admin by any means. This is the thing that will run at process ID 1. And generally on most Linux machines like this, the thing running at PID1 is, I can never remember the name of it, but it's a process that runs, and its whole job is to, as the machine is shutting down, to find running processes and try and shut them down gracefully, okay? This, for a container, generally you're going to have one process per container, one app per container. That's the job of a container, okay? If you get out there, there's some videos from DockerCon 16, I think, or 15. One of the engineers from Docker, she runs everything in a container. So she runs her Spotify in a container. She runs her email in a container. Now that's a little overkill, but she wanted to try and figure out how to marry the container's sound card to her physical sound card in the world, right? But this bin bash is the thing that's going to be running at process ID 1. The other important thing about PID1 is the fact that it's the thing that keeps the machine running. When the process running at PID1 exits, the machine exits, okay? That's important because when I run this, oh yes, I forgot. Bin bash is the last end, back into that command. This is what happens when you practice something and you put in the wrong command. Okay, so now we'll see root at some little hash there. And basically the container's running and I'm inside it. Actually, the container and my shell have now married. So when I do something like list out the directories, it looks like just a regular old Linux machine because it is. Okay, Nginx is basically a regular old little Linux machine. So, actually, if I open up another terminal here, and bump that up some. If I want to see the running containers on my local host, I run docker container list, which I really actually want to kill somebody for this command because the old command was docker ps. So having to type out container list is just killing me. Okay, now the old commands still work, so if you want to be one of the cool kids and use the old commands and make everybody think you're smarter than you are, which is why I like the docker ps command. So if I look at docker container list, we can see I've got the container ID, which is that 7AF70 whatever, which looks a lot like 7AF70 here, so I'm in that machine. The image is based on, this is the image that created this container, Nginx 1.13.12. The command that is keeping that machine alive is the bin bash, or the bash shell. It was created about a minute ago. It's been up for about a minute, that's the status. It does have a port open because it's Nginx. Nginx is a reverse proxy, so it's got port 80 open. And it's called Practical Feynman. Because I didn't give it a name, just know, if you don't give it a name, and actually this is fun for me, I do this kind of whenever I'm bored. just run an Nginx container and see what name it gives it, because it gives it a name from a list of adjectives and a list of famous computer scientists' last names. So you'll get things like Angry Boar or Hungry Babbage, things like that. And actually, some of them I've had to look up. I mean, everybody knows Feynman, but some of them I've had to look up, like computer scientist Anderson. That's kind of generic. But, so now if I want to stop this container from running, I can either do a Docker, stop, and I can use either the container ID or this name, Practical Feynman, which is great until you get some, Russian guy that's really, really hard to spell his last name. But the good thing is you don't have to type out this whole thing. You only need to type as much of the container ID as makes it unique in this list. So this case, it would just be 7, right? If I had a bunch of them that started with 7, then I would have to go 2 characters. By default, I just automatically type 3, because generally that's enough to get me, unless you have a bunch of the same type of image, like a bunch of different versions of Nginx on your machine. Most of the time, the hash for it is going to start. The first 3 characters is going to be enough to make it unique. But we're not going to stop this here. We're going to stop it over here, inside the machine, because the thing running at PID 1 is the thing that keeps the container alive, right? So if I just exit bin bash, then that's going to kill that machine. And now when I do, let me move it back up to the top here. When I do Docker PS or Docker container list, I don't have any containers running. Now the container's still there, it hasn't gone anywhere, it's just not running. If I want to see all containers, whether they're running or not, I can do a Docker container list with a -A on the end of it for all. So show me all of them whether they're running or not. And I'll see that same image, bin bash. It was created 4 minutes ago and it exited with a code of 0 35 seconds ago. A code of 0 is good. That means that nothing went wrong. Generally, that's the first place you can start when a container crashes, is by looking up that code. Or you can do Docker log in the container name and it will give you the log from that container. Okay, so now if I want to get rid of this, let's say I screwed up and I didn't want it built off of this, or once we start getting into Docker files, I screwed up the Docker files, so I want to get rid of this container. The way that I do that is by doing a Docker remove, and then again, I refer to it by either the first bit of the hash or by Practical Feynman, okay? One of the things that I think is probably highest on my wish list for Docker features, that's probably lowest on their list, is code completion or, you guys didn't see that. Actually, a lot of the time when I'm typing these out, I'll want to just get the image name done, and I'll hit tab to try and code complete, and it doesn't do it, and it infuriates me. But, so I'm going to Docker remove this image. Now, with most Docker commands, one of the things that you'll notice is when a command succeeds, all you really get is the arguments that you sent to the command spit back at you, if everything worked. Otherwise, you'll get error messages, and their error messages are outstanding. Because generally they'll say, did you forget to put this in your Docker file? Wow, okay. So, now when I do my Docker ps-a, I've got no containers running or not on my machine. Now, let's not get out of this just yet. If I want to remove an image, so I've got latest on my machine. And Lee said, never get latest, never use latest in production. Now, I didn't say never get latest, but never use latest in production. So I don't want somebody using latest in production here. I want to get rid of that image. And the way you do that is by doing a Docker RMI, or remove image. And the same thing, either enough of this image ID to make it unique in this list, or by using its repository name and tag. So could be Nginx 1.13.12. Or if you happen to have latest. Now you can still say latest, but you don't need to. And Docker RMI, again, well, let's go ahead and do it. test code completion. That so chuffs me right now. Okay, so when I do a Docker RMI with the Nginx and the tag, you'll see that it untagged the Nginx, and then it deleted a bunch of files. Each one of these files is a layer, and Docker images are made up of layers. And the topmost layer, the outermost layer, is the only layer that's writable. All the other layers are readable. And the reason I bring this up is we're going to get into Docker files in just a minute here, and it's important. Every time you add something to an image, it creates another layer over that image. The cool thing about that is if I have 10 of the same kind of similar images, it doesn't actually have to store the whole image, each one of those on your machine. It only stores what's different. So if the first 3 layers are the same across 10 images, it's only got those 3 layers one time. And then it only stores for each image what's different. So we'll see that this deleted a bunch of layers. And if I had had latest on my machine and 1.13.12, which is actually the latest right now, and I deleted latest, removed latest, you'll see all it did was just untag it, okay? So Docker's really super efficient about how it stores container images. Now again, I probably don't run the Docker run command very often. Generally the way I start up an image or build an image from a container, or from another image, is with a Docker file. And it's important to note that Docker files are ways to build images and not containers. Can everybody read that okay? Okay. So a Docker file is just a text file. It just happens to have a special name. Docker file with no extension and capital D for the beginning. You can call it something else, but it makes running the Docker file or creating an image from that Docker file a lot harder because you have to specify the file name every time. By default, Docker is looking for something called Docker file, capital D, no extension, okay? And it's just a text file, but it's got a bunch of simple commands in it. Things like from, copied, workdir, arg for creating variables, okay? And what I've got here is the first line of any Docker file is the from line. You can have comments above the from line, but you can't have anything else before the from line. If you wanted to create an image that's not based on some other image, I don't know why you would want to do that. Don't do that to yourself. But if you wanted to, if you're into self-mutilation or something, you can do from scratch. Okay. But this one's based on the node 8.4 image. Okay. So I want to create a new image based on the node 8.4 image. I want to copy everything from my local directory here into a folder called /app in the container. Then I'm going to set the working directory to /app. Now this is important. The workdir command is a little bit special because once you run this, everything that follows will be run in the guise of that /app folder. So anything that runs after this, it thinks it's running in the /app folder in the container. Now there's 2 ways to run commands inside of a container from the Docker file. There is run, and there's this thing that's called the exec style. This style here is called the shell style. The exec style is basically just a command, and then it's an array where the first item in the array is the command you want to run, and all the rest of the items in the array are the arguments you want to pass to the command. Okay? And you might think, why would anybody do this to themselves? It doesn't happen very often, but a shell style command runs as the guise of the root user, and it runs under the guise of a shell, where this does not run under the guise of a shell without any permissions. And according to the documentation, of course it's been a while since I read this part of the documentation, but this is the only one that's guaranteed to run after the container is up. Okay? Now I've never had one of my Docker files fail because run something, some shell style command wasn't ready. The container wasn't up and ready yet. So I've never had that happen, but it could be just because containers are so fast. But according to the documentation, this is the only one that's guaranteed to run once the container is up. So we're going to run a command called npm install in the /app folder, and we're going to run npm start. for our image. Now, if I wanted to do this, if I just wanted to build the image, I could come over here and just run docker build, and I'm in that directory currently, right? So I'm in the directory where that code exists. So I could do a docker build and just build from that local directory, and it's going to look for a Docker file called Docker file no extension capital D. Or I could do this and give it some other name. Okay, but I just want to build this one here locally. Now I'm not going to do that because generally Docker files for developers at least, and that's what we're talking about here is for developers. So we're not going to talk about a lot of production stuff. We're going to talk about how to use this as your development environment. Okay, so I'm going to look at my Docker Compose, and if you're running on a Linux machine, just know that you have to install Docker and Docker Compose separately. Okay, on Mac and Windows, it's all part of the same package that you download, double-click install. Okay. So a Docker Compose file is a YAML file, and by default, it's going to be looking for something called docker-compose.yaml. Well, I have one here called docker-compose.dev.yaml, and this is going to be my development compose. One of the things that I hate, although sometimes there's no way around it, I generally put development-specific stuff in my compose file and not in my Docker file. I want my Docker file to be as close to the production environment as it can be. Okay, the Docker Compose is the thing that I'm going to use to bring up a container from this Docker file, and that can be specific for my dev environment, but I try and keep them as similar as possible. So the version is the first thing, and 3.3 I think is the latest, maybe not. This presentation's a little bit older, but I think I've updated everything in the last 6 months. So version 3.3, version is the first line of any Docker Compose file. And the next thing is services. There used to be a thing called networks in Docker Compose before 3.0, but that's actually not needed anymore, but it's important because I'll show you why it's important once we start talking about the services. So I have services here, and you can call these whatever you want to. I've just called them web and Postgres. So basically, I've got this project here is just a little web app, and it's going to need a Postgres database to talk to. So I can spin these containers up together. And before, you used to have to come down here and add a networks, and it would network those two containers together, and they could talk to each other. But since 3.0 of Docker Compose, it actually does that for you now. So it'll create a network and put web and Postgres in it together, okay? So they can then talk to each other. So let's take a look at web, because it's simple. It's going to use our Docker file, and we're going to call the image workshop/node app, okay? Or actually, if I was smart, I would call this Brandt/node app so that I could push it to Docker Hub, right? But this is the image name. This is the container name. It's just going to be called web, so I won't get any angry Babbage or Hungry Boar. The build context is my local directory, which means it's going to look for a Docker file, capital D, no extension, in the current directory. This is the next thing that's kind of cool. I know, I'm not opening up any ports here, but I know by default the node 8.4 image has port 3000 open. So this is called mapping the ports to the host. So this first number is port 3000 on my host machine and port 3000 on the container. And I'm marrying the two of them together, which means that I'll be able to go to localhost port 3000 and be hitting the container at port 3000, okay? And this is important for development because then I can just open up localhost 3000 and I'm hitting the container. I've set some environment variables here, like the node environment to be developer, and the database URL to be this KCDC. By the way, I run a conference in Kansas City called KCDC. This is kind of the API for it, or at least a stripped down version of it. So this is the connection string for the database. This second one is the second part of cool unicorn magic of the Docker Compose file. I'm like leaning this way and talking to this whole inside of the, I'm sorry, you're not like redheaded stepchildren or something. I'm sorry, I'm not trying to ignore you. Cool thing about volumes is it marries my current directory, this dot, to that /app folder in the container, which if you've ever used something like symlinks or mounted volumes, that's basically what it is, okay? So when it thinks it's going to /app in the container, it's actually going to my local directory. This allows me to run the container, change code in my editor here on my local machine, and actually have it be running in the container, okay? And the entry point is going to be npm run dev, okay? Because that's in my package.json file dev, which is just nodemon. Okay, so it's just a little node app. Now, the second service that I want to start up, or the second container, and it's important, services and containers kind of mean the same thing, especially when you start getting into stuff like Swarm or Kubernetes. A service is a container or a set of containers. So the second thing in our services is this Postgres image and container that we want to start up. We're going to build it, wow. We're going to build it based off the Postgres 9.6.3 image, okay? The container name, once it's spun up, is going to be called DB, okay? I'm going to marry port 6432 to 5432, and that may seem weird to some of you, but I have Postgres running on this machine, so port 5432 is actually taken on this machine. So I have to map 5432 in the container, which is the default port Postgres runs on, to 6432 on my local machine. I'm going to set up a couple of environment variables, and these are important to Postgres because Postgres will use this to say, hey, create a database called KCDC when you start up this image. And so create a Postgres user, and I could set a password here as well, called KCDC_app so that I can log into that database. Okay? These two volumes, just like the volume before, it's mirroring this .sql directory, this guy right here, to a special folder in the container called docker-entrypoint-initdb.d. And this daemon folder, all it really does is finds any SQL it can find in that folder and runs it against the database that it just created, okay? And this one, /db/dev here, is going to be mapped to var lib PostgreSQL data. So anybody who's ever done any database development, you know the database is not some mysterious thing. It's generally made up of just a couple of files. Well, Postgres is made up of a bunch of files, and they all live at var lib PostgreSQL/data. So mapping this to my local machine means that the database actually lives on my local machine. And this is one of the things that you'll probably want to keep in production because containers are meant to be destroyed and recreated all the time, okay? So if I want that data to live beyond that container, then I need to create a volume so that that data is actually saved out to a host machine somewhere. Does that make sense? Okay. So that means I can, and you'll see it here in a minute when I spin it up, because even though you can't see it here, if I go to open containing folder, and I try and go into here, it's going to ask me for my sudo password because regular people don't have access to this directory. But these are all the files that make up a Postgres database. So that just means that I can destroy and recreate this container, and the data that's in the database never goes away, okay? Because containers are meant to be destroyed and recreated all the time. That's how you update them. Basically, the way you update a container is by creating a new version of that container, destroying the old one, and putting that one out there. That's the way updates happen. So, if I go over here, how are we doing on time? I'm about 2 minutes over. But I can do a Docker compose. Wow, it's not going to help me at all. -F. Now will you help me? No, you will not help me. Docker compose .dev.yaml up. And really the command here is just docker compose up. But I have to give it the file switch because by default it's going to be looking for docker-compose.yaml. So by telling it the file name is actually docker-compose.dev.yaml, I'm running a different docker compose. So when I run this, you'll see building web, which looks suspiciously like our Docker file here, each one of those steps. And this is another thing that I wish NPM would do differently, but all the NPM run is run in red, which immediately makes me think something went wrong. But NPM info, okay, so I think Art was talking about that holy war thing. So NPM worked, everything looks good, and down here it says nodemon started watching here. So I should be able to come over here, go to localhost, port 3000, and it's actually my Docker container. And now I can come over here into my development environment, and I can make changes to these files. So where's my index route? So we'll say really, and when I save this, and I jump over to my command line, we'll see that we saw nodemon was restarting, or you might not see because it's behind my fat head, but said nodemon restarting due to changes, and then now it's starting in that folder again. So if I come over here and refresh the page, it's really, okay? So now I can do my development all day, and so my workflow kind of looks like that. I come in the morning, Docker compose up, work. When I get done, I do a Docker build for the Docker file so that it actually copies all the latest files over into the new container, and then I push that up as an image to Docker Hub. And what is really super cool about this is, actually, I want to hit the API endpoint too. If I go to /users, we'll see a bunch of data from the database, so it actually is querying the database. But what's really cool about this is, how many people have ever been on a team where you're the front end or back end developer, you're the front end guy, and the API team just pushed a broken API? And you're just like, okay, well, internet's broken, I'm going to get bagels, I'll be back. So one of the things that this can help with is I can actually run the API locally. I don't need to worry about it, right? I can get the latest version from Docker Hub or whatever our local repository is. I can get the latest version of the API, pull it down to my local machine, and run it in my development environment. And that way, the API team can do broken stuff all they want in a test environment, and as long as they don't push that to the latest image, or to whatever image you're pulling down. So it allows the two teams to now work a little bit more separately. And same with the UI. The API team could pull down the latest version of the API or the UI image and run their API against the latest version of the UI and make sure that everything's working like it should, okay? Without having to bother the UI people or anything, okay? So, I've got about 2 minutes left. If you want to try out Okta, you can go to developer.okta.com. There's lots of tutorials, SDKs for all different languages. I am lee.brandt at okta.com if you want to send me questions, comments, or you can follow me at lee.brandt on Twitter. Please do that because they're really, since I'm a developer advocate, they're really bummed about the fact that I only have a couple thousand followers. So the more followers I have, the more money I get for my job, so thanks if you follow me. So, any questions, comments, concerns? Wow. Either I'm a really great teacher or y'all just woke up.
And keep your hand up. I'll come find you afterwards.
I'm a Windows guy.
Okay.
And our development environment's in the cloud, and we work
Okay.
off a VM. We're having the problem of nested virtualization at the hardware level. What is your suggestion on how to get around that?
Nested virtualization, you mean like having a VM running on a VM?
Yep, the ghost VM that runs the Linux operating system that Windows actually puts the containers on won't start because we don't have nested virtualization. So would you suggest not running Docker at all on top of the VM, remove VMs from the situation, or?
Well, you're running on Azure?
Yes.
Okay. So one of the things that Azure has is containerization already turned on for certain things. So instead of using a VM, you can use one of the containers. If you search for, what is it, app containers or container systems or something like that, they have two of them. One of them is for just a single Docker file. You give it a place where a Docker file lives and it'll create a container for you. The other is containers services or something like that, and it will run and it'll ask you what orchestrator you want to use, because it's basically made for running multiple containers. So you'll ask you whether you want to use Swarm, Kubernetes, or Apache, Mesosphere, DCOS, whatever. So it'll ask you those things, and I would move it over there. Then you don't have to worry about the VM being underneath it.
All right, thank you.
Who else?
Just one comment for the RMI steps for the removing images. Don't forget the force switch, because on like for Ubuntu and stuff like that, like sometimes what you'll have is you'll actually have to like force some permission to actually like get that thing to shut down and like remove it.
Yeah. And I'll show you one other little command that I use. Actually, this is interesting too, because since we're in interactive mode, if I didn't want to run this in interactive mode, I'd have to add a -D. But since we're in an interactive mode, I Control-C to get out of this. And on Linux, it works a lot better. But on Mac or Windows, only about half the time do I get stopping, done. Most of the time, it'll be stopping, aborted, or failed. And then I'll have to go and clean up the images. But I've got my Docker images over here. The good thing about even when you're running on Windows or Mac is it's still a Linux machine underneath covers. So I can put the output of one command to the output of another command. So if I just wanted to clean up my machine, and as you start experimenting with this is going to be super helpful for you. This will remove, you guys can't even see that, can you? Okay, this will remove all the current containers on my machine. The -Q just means quiet, so it just outputs the IDs of those containers. So when I run this, it's going to output the two IDs of those containers, and it has actually removed them. So I don't have any containers on my, and you can do the same thing with Docker RMI.
Who else?
So you showed a container, Postgres container that you ran. Is that something you would actually do in production? Are there performance implications to running certain kinds of services like databases with Docker?
Not that I've seen. I know that Okta uses all of our stuff is containerized. All of our stuff is Java. Well, a little bit more vomit, but it's all hosted on AWS. So it's all microservices in containers, and I know that our database is also in containers. So I haven't seen any performance problems now.
Oh, thank you.
Yeah.
So I work in an environment where, due to various management constraints, everything has to be on premise, and we frequently have to proof of concept stuff for the benefits before we can, get actual server spun up. So if hypothetically I wanted to, proof of concept use of Docker, but I could not host stuff on Docker Hub, and I needed some way to share Docker images internally without the server beforehand, what sort of strategies are there that could achieve that?
Okay, so Docker Hub does have a container that allows you to host your own Docker repo. You can set up a Docker repo on your local machine as well, or on a server that you already have access to on your network or something, and allow people to pull from there. It's just Docker pull, then you have to give it the arguments of what repository you want it to go pull from. So our Docker pull and the image name, it assumes you mean Docker Hub, but you could provide like a directory or a URL to go and get from somewhere else.
Does it pull over HTTP?
HTTPS, yeah.
Awesome.
Anybody on this side?
Now the next question
Okay,
will come from over here, because I want to see how fast he can get from.
I have a,
I'm just gonna throw it.
so I have a Docker and Node problem where if you do an npm install on the host system, you get some of the packages are OS specific, and then you run Node in the container and it picks up the Node modules, and then you get all sorts of problems because the libraries are wrong.
Yes.
And then the solution is wipe out the Node modules directory and then do the npm install inside the container again. So my question is, why is Node winning?
Why is Node winning? I don't think it is, actually. I think it was because JavaScript's eating the world, and because people are like, if only I could do JavaScript on the server. Why, I don't know. But actually, Go is starting to win now, which I'm glad to see. I'm starting to learn a little bit of Go. It's a pretty cool little language, but like Disney is using it, but still, Walmart's using Node.js. There's lots of big Node shops, so I think that's the reason Node is winning, because it was the cool new thing. Now it's kind of, I guess all the hipsters are going to have to go over to Go now. Any other?
Final question?
Yep.
We're planning to tag our Docker images with the Git commit hash. Is there any advantage to using semantic versioning for the tags instead of a commit hash? Or what other method would you use to tag the images besides latest, since that's not advised?
Actually, so one of the things that you'll see out here on Docker, let's search for the Nginx one because I know that one better. Come on. So when I look at the Nginx one here, you can tag it multiple times. So it's got one called mainline. You can call it whatever you want. And latest is always going to be there, but that's the latest one. So I could do a Docker pull Nginx 1, 1.13, latest, mainline, or 1.13.12. All of them get the same image. And actually, if you're ever interested, you can go out here and look at the actual Docker files that make these up. And, oh, something else that I should mention. For the shell style commands in Docker files, there's two things you can't do in the exec style that you can do in the shell style. One is you can use variables. So if I wanted to set up an argument up above or read in an environment variable and then use that in my setup of the Docker image, I can do that choosing the shell style. The other thing is, and you'll see this a lot, because everything you add to an image makes a new layer, in order to keep the layers kind of semantic, you'll see these ampersands in here. You guys probably can't read that, but. So this apt get update, and then it's going to run these get commands. Those sorts of things can all be kind of glued together with ampersands, and it makes the layer a little bit more semantic, right? So now if I want to get Apache onto a machine, generally when I put Apache on that image, I want Apache utils with it. So I just install Apache and Apache utils in one command, and it makes one layer that has that in there. Does that make sense? Cool. Thanks very much. We're going to have a break here, I suppose.
Yes, sir.
Okay.
Ready to get up for Lee? We're going to have a 5-minute break real quick, and then we'll get started with the next speaker.